Wanted to try a new thing that I got and use it to demonstrate a point with trees because I'm just trying to grok this, right? So actually, maybe I could work on getting like a full page, but I mean, for our purposes, this is fine. That's big enough, so I'm gonna undo. So if we want to know in a tree, right, we have a tree here, how many, I gotta get used to drawing, but let's say we have a tree here and we want to know how many nodes we have in total, right? How many nodes we, how do we, okay, how many nodes we have, okay, I can't circle that. How many nodes in total do we have in here? Well, we can count 1, 2, 3, 4, 5, 6, right? And how do we know that? Well, let's complete it. So we'll have a complete binary tree over here. How do we know that? Well, there's a way to know this, right? So everything is, so at max, each node has 2 children. So we can say at the first node, right, here we have 2 to the 0. Jesus. 2 to the 0, right, which equals 1. At this level, so let's say, okay, let's do this. 2 to the 1 equals 2, right? And 2 to the 2 equals 4. So we have 4, 6, 1, 7 nodes here. Now, let's say this power exponent equals k, right? So let's say 2 to the k is how many nodes we have at that level, right? So 2 to the 0, blah, blah, blah. Now, if we wanted to know the total number, we would have to add, 2 to the 0 plus 2 to the 1 plus 2 to the 2, on and on and on, right? Until we have 2 to the k, right? So that's what I meant by 2 to the k here. So if we have that, then we'll have the total number, which, I mean, is going to equal 2 to the k plus 1 minus 1. Now, this is something that was just on my head, but if we were to try to understand that, it's like, so what is k here? 2 to the, let's say we had another level, right? 2 to the 3. So 2 to the 3 would equal 8, right? By 2 powers. So at that level, we would have 14, 12, 14, 15 nodes in total, right? So what's 2 to the k here? 2 to the 3 plus 4. 2 to the 3 is 3 plus 1, 4. So 2 to the 4 is 16. 16 minus 1 is 15, right? So that worked out, right? 12, 14, 15. Yeah, how did that work out anyway? It's like, if I feel like because we have this one node here, it's always uneven. That's why we need to subtract by 1. But anyway, so I thought this was pretty neat, just to remember that, to know that we want the total number of nodes, we could just use this formula, right? Yeah, k being the level where you want to end up. Okay, good practice.